Hi, it's Petey, and I wanted to document this real quick. Plus, I figure I could take this opportunity. Maybe this information would be helpful to somebody to help you learn how to do something that you think that you probably couldn't do. Here is a circuit. Oftentimes, you'll see me holding something like this in a photo. If you're one of my Facebook friends, you see me holding something up going. And that this is usually it's something that I built. Now in this case, a good friend of mine sent me this wah-wah pedal. It's called a Schaller Bow Wow Yoi Yoi, and there's a switch on it. When you hit that, it'll change its sweep from wow wow or bow wow, they call it, to more of a like a yoi yoi. Now when I got this, I was told it needed to be rewired for the switch. And then when I actually started looking at it, I was just pulling pieces of wire out of it. Here's some of the wire I pulled out of it. There's more pieces here. Yeah, it was there was the battery clip was missing. It was in there, but it wasn't connected, and all the wiring had been cut, and someone had wired it up as a volume pedal. I guess they didn't like the wah, and they thought, you know what, I can rewire this as a volume pedal, and they did. They disconnected the pot, which is this little guy that spins around, okay, and wired the input to the output through this pot. And then that had been cut on one side, and that was gone. So I kind of had to deduce that, what had been done to it. Looked like several people had maybe messed with this thing. And I had no clue as far as looking at the board. It's not labeled. There's one post. There's one post down here. There's one post in the middle, and then there's there's 5 on the top. And I mean, technically here we would have a main ground, we would have the 9-volt power input, we would have the audio input and the output, and then the 3 connections that would go to the outboard to the pot, and then there's also 2 wires to go to the switch. Now thankfully enough, the switch was wired. I didn't have any question about that. And as far as me fixing this, my heart sank, and I was like, there's no way I can do this, because I didn't know where to hook anything up. And oftentimes that's the case. But within about, how long would you say, a half hour?
Probably, if not, less.
Less than a half hour. I've got it working. Now, I'm not 100% sure. There's a few different ways that the pot can connect. But as it is of now, I'll demonstrate this for you. There's a Schaller Bow Wow Yoi Yoi original unit. This is an original. There's a Model 2 that's a little newer, but there's an original unit on reverb.com for $599 with $19 or $16 shipping. So this is something I'm going to want to repair this. Not to sell it, but to keep it for my collection, because that's what I do. I make music with this stuff. So right now I'm going to turn my test oscillator on. That's this device. RG Keen's Quick and Dirty QND test oscillator. If you build stuff and you don't have a test oscillator, well, that's your business, but I use this anytime I'm testing anything. I know guys will say, why don't you just plug your guitar in and then play constantly be playing, or call your spouse in to hit an A. That's a real good one. Remember those days? So yeah, this thing And then here is a miniature LM386 based first act test amp. And yes, I've built a bunch of LM80 tricks, Tiny Cricket, Noisy Giant, all that crap. I don't play around with those. I build the TDA 7052A is the chip that I use. It's called a punch amp. It's twice as powerful, and it doesn't have any of the issues. Yes, if you built a Cricket, a Gem, they don't play clean. It always has dirt, and it has nasty artifacts on the release of the note. So this is something I use as a test amp, and I'm going to spin the treadle. Now I'm going to throw the switch. I'm guessing that's the yoy. So there you go. So how did I do this? Well, I Google searched images of the Schaller Bow Wow Yoy Yoy, and there's different versions of it, so it's all hit or miss. One version of it showed me the battery connector coming in where the red wire went. There was a post in the middle of this PCB I hadn't noticed. When I saw that, my heart went up and I thought, I'm going to be able to do this. The other switching, just by looking at it, from left to right, I'm thinking this is German. I bet you the left is the input, and all the way on the right is the output, and it is. I was able to look at another picture, and just by looking at these images and where they went to, what I knew on the photo, like I had gotten a diagram of how the switch works from Google searching. I found people were talking about it, and the guy had posted an image that was down. That image wasn't up anymore. Well, I emailed that guy. I contacted him. You might have to join a forum. You might have to ask around. You might have to find somebody that will answer you back, that could get in touch with the guy for you. But there's ways where you can hunt down this information and ask people nicely. There is another YouTube channel where a guy rebuilt one of these. I went on his channel and I left several positive comments on his work, and then I politely asked him if he could give me the pinout for this, and he never responded. That guy, his name is, I won't say it, but that's not cool. We need to help each other. If somebody comes to you and asks nicely, especially if they're going to take time to check out some of your other work, subscribe to your channel, comment on your work, and compliment you. Yeah, it's kind of a brown-nosed thing to do, but I meant what I said, everything that I said, because I did like the guy's work. It was cool work. Why he didn't answer me, that's beyond me. Too busy cycling in Vegas is my guess. Now, basically, what this came down to was I knew where the red wire went, the positive wire going into the board, and then at that point I saw that there was a group of 3 leads all soldered to one post coming off, and I'm thinking that has to be the ground. So I used what's called a continuity test, and that's a very useful function on your multimeter. So this gives you the music when you connect, when it goes through. So I put one side of the meter on that group of that solder point where the 3 wires are coming out, where I'm thinking, I bet that's got to be the big common ground, because there's 3 wires coming out of it. And then I went and I looked for electrolytic capacitors that have polarity, and on those they'll be marked which side is a negative, and I will connect to the minus side with the other probe, and if I hear the music, that means I'm probably on a ground. And then I look at the schematic and I see, oh, that's a 47 UF capacitor, and it terminates to ground on the schematic, and then I'm looking, It sure is. And right next to it, here's a resistor. I can test that. They say, oh, don't test resistors when they're in the circuit. They can give you false reading. Well, that's true, but I test resistors when they're in the circuit, and they almost always tell you what you need to know by being ballpark or close or right on, depending on how the circuit is. It could be right on. And the other way of identifying the resistor is the color bands. So if you can get a hold of the schematic by slowly looking at it and determining what the parts are, you see, well, the input comes in and there's a 22K resistor right there, and it also T-bones to a 0.022 microfarad capacitor. So then you need to find those parts on the board. You need to look, well, there's 5 ports where there's a solder blob on a terminal where the thing comes out. It breaks out of the circuit via a wire. And we need to determine what those 5 points are so we can hook up the input, the output, and the switch. So by kind of common sense and deduction, by looking at the schematic, if it's labeled on the schematic, you can figure it out in real life just by deduction, by figuring out what the parts are. So real quickly, I was able to do that and get an overall confidence for what I thought this was. And as soon as I had that confidence, rather than try to go through the whole procedure of installing it into the chassis and wiring all the extra stuff up, the bypass switch, the part where the power routes through the input jack, so when you unplug it, it disconnects the battery, all that other hanky-panky, I just wire up a direct test rig. I soldered up 2 jacks with leads on them for the input and the output. And I'll use those wires. Everything, all the work that I did, I'm going to use. Because basically, all I needed to do was test my theory of, am I correct with the pinout, and is the board working? So, soldered the red line, red wire into that post that where I saw a picture of the battery with the red wire coming out and going into here. I soldered a red wire there and a green wire to that group ground, and then connected my battery clip. And then I had 2 jacks. I had a black wire for the ground and an orange for the output, and then a yellow for the input and green for the ground on that one. So I put both of those ground wires to that mass center where the 3 prongs were coming down into one, and I had tested it out and it canted out to the minus side of a capacitor. And then I hooked my inputs up to where I had looked at the schematic and seen that not only were the parts where that port came in the same, also the wiring coming off of it, there was a picture of these 2 orange wires going back to the switch that were connected to the points that said circuit in, circuit out on a diagram that I had gotten from that guy. So that told me, everything I needed to know, where the input and the output are. And then the switch was already hooked up, so the last thing, that left 3 wires. And those wires go north. And so I pulled them tight, and they were kind of staggered, which would tell me that if the pot sits this way with a 1, 2, 3, the short wire goes here, the medium wire goes there, and the long wire goes to the long side of it. And even if I wouldn't have known, one of those wires was to a ground, and I looked on the diagram, and I know that it's a blue wire here. So all I need to do right now, the only thing I could have done wrong was flip-flop 2 of these wires. So before I celebrate too much, let me see what happens when I... And again, this is... my job's not done. I'm going to want to have 100% confidence So what I'm going to have to do, besides just this test, I mean, maybe this test will tell me if it doesn't function. The other thing would be once I install it with the treadle, how this pot actually turns with the mechanical connection it makes inside the contraption. Is if I have the wires hooked up, it won't if they're 180 degrees flipped. I'm guessing that might affect the performance of the device when I have it completely put together. And then it's at that point, I don't like to work that way. I like to do it right the first time rather than slapping it all together and crossing my fingers. This is it's more of an educated guess of educating myself as far as how the board works. Because when I first looked at this thing, my heart just sank, and I'm like, oh man, this is going to take me, it's going to take me forever. It's going to take me a couple of days. So yeah, that's definitely not it. I had actually, that's when you solder onto a circuit that's live. Sometimes you'll hear the, actually you're hearing the AC coming through and being amplified by the circuit coming out of the amplifier, and that's not very pleasant. So what we're going to do now, I'm going to hook the pot up and flip the outer two wires just to make sure. I mean, this will probably work here because of my knowledge of pots and how to wire them, but it will reverse the throw, meaning before when you went wah, wah that way, when you flip the wire, it'll be ow, ow. So it's not gonna work well if you hook it up wrong. And okay, so welcome to Torture Time with Petey. Luke. Alright, what do we got here? Yeah. When you flip-flop them, it does kind of what I would expect, which flip-flops the operation of the pot. So, I guess if you want me to like demo this thing, oh my god, I think the landlord's here. No, it's the people across the street. I've got a security camera and I can see the parking lot. We had the siding was blown off of the building. The aluminum siding came off, and there was a piece hanging by the. There's an alarm lamp that when the fire alarm goes off in the building, it's a strobe signal on the building. All the buildings have them, and that's so when the fire department come, there's so many similar looking buildings in this area, they know right away without having to figure out reading addresses, that house is blinking, that's the one with the alarm going off. Well, when the siding got ripped off from the violent wind, a huge piece of siding was bent around the wiring, pulled out that signal lamp, and it was swinging around. And the village put a citation on our building to have that repaired. And I was working with the landlord on taking care of that. And I tried myself. I used electrical tape and taped together 3 6-foot poles to make this like 15-foot pole, and tried to get it off of there. And then he called some guy with a ladder to come today. and that guy came early in the morning, and I slept in and missed it. So I might be in a little hot water with. You know what? If he had the guy come out, the guy had to come out. You know.
He didn't leave a message.
He didn't leave a message, so he called, but he didn't leave a message, and I slept in, so I'm a little bit paranoid about my landlord. Anyway, open the door, Ma. These are our neighbors that just yell. Hear them? See if I can hear them. Joys of apartment renting. So, if you want me to do a demo of this thing, maybe I'll do that at some point. Let me know if you want me to do a demo of this thing. But that's how you get your confidence high when you're faced, when you get something and it's torn apart like that, and you think, oh my goodness, this is really complicated. It's going to take forever. It's process of elimination. You just start having to check one thing off and use your best knowledge and your best hunches, and then set up a test. Because it's not that, this stuff really isn't that complicated. There are some people that will pretend that this is wizardry and it's alchemy. It's not. It's not. Most of the circuits that work well have been done and redone and redone. There's only a handful of circuits that really do the job well for this type of thing. So those designs have been done and redone and redone and redone and redone. And even inside of those, we see similarities in concepts and structure. So it's not really that complicated. It is time consuming, and it does call for some creative thinking. And that's what I wanted to try to show you here today, was how I went from thinking I was never going to be able to do it to getting it working in under a half hour, which is pretty cool. Thanks for joining me. And another thing, I'm probably not going to be able to help you. The time you take typing that question to somebody online is time you could spend taking a break to walk it off or look something up, find some more information that would be more helpful. Because a lot of people will ask questions, and you have to think about the question you're asking. Is anybody going to be able to help you with that in DIY? I see that a lot. And in the forums, there are certain people that, because they claim they're from another country, or I don't know why, but they get carte blanche and people hold their hand. There's one guy that's been there for years now, and every time he builds anything, he's in there saying that everything he didn't work, and it's always him. He's always hooking it up wrong. He doesn't know what he's doing, and he's so nervous and asking everyone. I'm thinking, like, if you just built this stuff on your own and had a little guts and experimented on your own, you could figure all this out on your own. So that's kind of what I'm bringing you today, is rather than reaching through the internet and trying to get somebody to come through your monitor and do your work for you, you need to do it. And Google is your friend. Google image search. That's what you're going to need to do. You need to get a copy of some software called View and get good with that. Get good at, like, another tool is called Gadwin Print Screen, and that's when you're not allowed to download an image. You can create an image of your desktop. So whatever is in your browser, even if you can't download it, you can capture that as a JPEG and then edit out the rest. You pull up the JPEG in View and make a box of just what you want to save. Hit Control Y and that crops it. Control S, enter, left key, enter again, and then it saves it as a JPEG of just that. And then you can blow those images up to get a clearer view at just the section of the wiring that you're working on. So those were the tools that enabled me to get to that confidence point and determine the pinout of the circuit that I'm working with today, and as you heard, I got it working. So it's just going to be a matter of time before I can box this one up and box this one up, and that'll be that.